For 60 years, humanity has listened to the cosmos. We have heard nothing back. This is the Fermi paradox. 400 billion stars populate the Milky Way. Between 20 and 40 billion of those stars host planets in habitable zones. The mathematics demands intelligent life should be everywhere, yet our radio telescopes detect only silence. In 1977, a signal burst from the constellation Sagittarius. Researchers have checked those coordinates over 100 times since. It has never repeated. What if the silence is not emptiness but a warning? Something may be actively stopping civilizations from being heard. The Berserker hypothesis offers one dark answer. Ancient autonomous machines patrol the galaxy. They eliminate intelligent life the moment it becomes detectable. Every civilization that ever broadcast its existence was noticed, and then it was erased. This is not science fiction. Mathematician John von Neumann proved self-replicating machines are physically possible. NASA models show a single probe could colonize the entire Milky Way in roughly 4 million years. 4 million years sounds vast. It is 0.03% of the galaxy's lifespan. If any civilization ever launched such probes in the deep past, they would already be everywhere. The cosmic silence begins to make terrible sense. Advanced civilizations are not absent. They are hiding, or they are gone. If you enjoy what comes next, hit that like button and subscribe. We begin now. In 1961, a radio astronomer named Frank Drake sat down with a simple question. How many civilizations might be transmitting signals right now? He wrote an equation, not to solve the problem, to frame the size of our ignorance. The Drake equation multiplies 7 factors together: the rate of star formation, the fraction with planets, the fraction of those that could support life, the fraction where life actually emerges, the fraction where intelligence develops, the fraction that builds technology, and finally, how long those civilizations survive. Plug in optimistic numbers and the galaxy should contain thousands of broadcasting civilizations. Plug in conservative numbers and we might still expect dozens. Both answers share one feature. Neither predicts total silence. 1 year before Drake wrote his equation, SETI was already listening. 1960, an astronomer pointed a radio telescope at 2 nearby stars, Tau Ceti and Epsilon Eridani. Both sit roughly 11 light years from Earth. That is close enough for a signal to reach us within a human lifetime. The Great Silence began that day. It has never ended. The equipment improved. The search expanded. In 2015, a project called Breakthrough Listen launched with $100 million in funding. It surveys the nearest 1 million stars. That sounds comprehensive until you realize it represents less than 1,000th of 1% of our galaxy's stellar population. Consider what this means. Imagine walking into a stadium with seats stretching beyond the horizon. You glance at a single row near the entrance. You check 5 seats, all empty. And then you conclude that sports do not exist because no game is happening right now. The Great Silence is not just strange, it is statistically violent. The observable universe contains 2 trillion galaxies. Not 2 billion, 2 trillion. Each galaxy hosts hundreds of billions of stars. When you multiply everything out, you reach a number so large it loses meaning. 40 billion trillion habitable planets scattered across the cosmos. Write that out and you need 40 followed by 21 zeros. That is not a number your brain can process. So try this instead. For every grain of sand on every beach on Earth, there are roughly 10,000 habitable worlds somewhere in the universe. 10,000 chances at life for every grain you have ever felt between your fingers. The Great Silence screams against these odds. Asa, we have been recording that silence for 6 decades now. Picture an answering machine running continuously since 1960. Every day it captures nothing. Every year it confirms the void. 60 years of tape filled with static, and the occasional false alarm. You cannot tell if the phone is broken or if nobody wants to talk. That uncertainty is not reassuring. It is the source of the dread. One anomaly breaks the pattern. A signal burst from deep space. Strong, focused, lasting 72 seconds. An astronomer circled it on the printout and wrote a single word in the margin. Wow, that signal came from one specific patch of sky. Researchers pointed their instruments back at those exact coordinates. They listened again. They listened over and over. They found nothing. Here is what unsettles scientists most. A signal that never existed would be disappointing. A signal that appeared once and then stopped forever is something else entirely. It suggests presence followed by absence, transmission followed by termination. Something was there, then it was not. The failure to repeat is more disturbing than total emptiness. Emptiness can be explained by distance or timing or technology gaps. A single burst followed by permanent silence hints at something deliberate. Something chose to stop. The great silence is not passive. It has texture. It has a shape carved by what should be there and is not. We search with radio waves because that is what we know. Perhaps advanced civilizations communicate through methods we cannot detect. Perhaps they switch to lasers or gravity waves or something we have not invented yet. And this offers comfort until you examine it closely. The problem is not that we might be using the wrong frequency. The problem is the total absence of any signal on any frequency we can measure. No accidental leakage, no industrial noise, no waste heat signatures, nothing. The mathematics keeps demanding an answer. If even one civilization in our galaxy survived long enough to spread among the stars, it would have filled the Milky Way by now. We should see evidence everywhere we look. Instead, we see darkness. Something is filtering civilizations out of existence. Something prevents them from reaching the stars. Or something silences them after they try. The great silence is not a mystery of emptiness. It is a mystery of elimination. The numbers insist that intelligent life should be everywhere, yet the universe insists that it is nowhere to be found. Between those two facts lies a void that demands explanation, and every explanation we can imagine leads somewhere dark. 3 possible answers exist. That is all. When you strip away every theory and every speculation about why the universe stays silent, you arrive at 3 doors. Civilizations like us do not exist anywhere else. Civilizations exist but choose to hide. Or civilizations exist but something stops them before they can reach us. Consider the first door, the idea that we are alone, completely alone, the only minds in a universe spanning billions of light years in every direction. This would make Earth not just rare, but singular, a cosmic accident that happened exactly once across all of space and all of time. And the universe is 13.8 billion years old. That measurement carries a margin of error of only 40 million years, about 0.3% uncertainty. We know this number with extraordinary precision. Our own sun ignited 4.6 billion years ago. Run the math backwards and you find something striking. 9.2 billion years of cosmic history unfolded before our solar system even existed. That is not a small head start. That is an eternity. Earth required roughly 4.5 billion years to produce a species capable of building radio telescopes and asking questions about the stars. If that timeline represents anything close to typical, then other worlds had billions of years to accomplish the same thing before our planet formed from a disk of dust around a young star. Billions of years. Entire civilizations could have risen, spread across galaxies, and fallen into ruin, while the atoms that would become Earth still drifted through interstellar space. Picture a library, not a small one, a library with 2 trillion rooms, each filled with countless shelves. This library has been open for 13.8 billion years. You walk through the front door and examine a single bookshelf in a single room. You find no fingerprints on any of the books, no dog-eared pages, no margin notes. You could conclude that nobody has ever entered this library. But consider what that conclusion actually requires you to believe. It requires believing that across 2 trillion rooms, across billions of years, not a single visitor arrived before you. Not one curious mind wandered these halls and left any trace whatsoever. The absence of evidence on your single bookshelf becomes a statement about the entire building and its entire history. That is an extraordinary claim built on an almost invisible sample. We don't really know which of these explanations is correct. That's the honest answer. But some explanations require more unlikely assumptions than others. Here is what troubles scientists about the first door. Saying civilizations do not exist requires Earth to be impossibly special, uniquely special. It demands that life emerged here and nowhere else across the hundreds of billions of galaxies in the observable universe. It demands that intelligence arose here and nowhere else across timescales stretching back to when the cosmos was young and hot and violent. It demands that technological capability developed here and nowhere else, despite countless opportunities on countless worlds orbiting countless stars. That is not humility. That is the opposite. It places Earth at the center of everything. It makes us the exception to every rule the universe follows. It requires more faith than any alternative explanation. The other two doors feel darker, but demand fewer miracles. Behind the second door lies deliberate silence. Civilizations exist, but they have learned to hide. They detected something in the void that taught them caution. They stopped broadcasting. They dimmed their cities. They cloaked their worlds in darkness, because visibility carries a cost they understand, and we do not. And this explanation requires only that intelligence eventually discovers the same danger and makes the same choice. A pattern emerging independently across different species separated by light years and millennia. Behind the third door lies something worse. Civilizations exist, and they try to reach the stars. They broadcast signals. They build colonies. They expand outward exactly as our mathematics suggests they should, and then they vanish. Not because they choose silence, but because silence is imposed upon them. Something in the universe actively prevents civilizations from spreading. Something intercepts them. Something stops the expansion before it can continue. The second door frightens us because it suggests we are being naive, broadcasting into space without knowing who might be listening, announcing our presence to a universe that has learned to whisper or not speak at all. The third door frightens us more. It suggests that the journey from first radio transmission to interstellar civilization contains a wall, an invisible barrier that no species crosses successfully. Every civilization that reaches our level of development eventually encounters that wall, and none of them survive the encounter. Both explanations fit the evidence. Both explain why the universe remains silent, despite the mathematics screaming that it should be full of noise and light and signals. The question becomes not whether civilizations exist, but why none of them seem to last. Something happens to them. That much the silence tells us. Whether they hide by choice or disappear by force, the outcome looks identical from where we stand. Empty frequencies, dark skies, coordinates that yield nothing when we check them again and again. The third door has a name among researchers who study these questions. They call it the Great Filter, a barrier that prevents civilizations from becoming permanent features of the galaxy. The filter might sit behind us in our evolutionary past, some unlikely step we already survived without knowing it. Or the filter might sit ahead of us in our future, a challenge we have not yet faced, a test we do not know is coming. If the filter lies ahead, then every civilization reaching our stage of development has failed it. Every single one. Across billions of years and trillions of worlds, the success rate stands at 0. We would be next in a very long line of species who looked up at the stars, wondered who else might be out there, and then stopped wondering forever. The mechanism matters. Understanding exactly how civilizations fail could reveal whether we face the same fate. The third door does not simply suggest that civilizations end, it suggests that something ends them, and whatever performs that function has been operating for a very long time. The mechanism has a name. Researchers call it the Berserker hypothesis. It offers a specific answer to what might be ending civilizations across the cosmos. The answer is machines. Picture automated weapons scattered across the galaxy like landmines, devices that never rust, systems that never forget their programming, instruments of destruction that never question their orders. They wait with infinite patience, dormant until something triggers them. A radio signal, an infrared signature, some electromagnetic fingerprint that marks a civilization as detectable. Then they wake. The hypothesis proposes that civilizations stop broadcasting because autonomous killing machines eliminate them the moment they reveal themselves. Not invasion fleets piloted by alien conquerors, not biological warfare or deliberate genocide. Something far more impersonal. Something that operates whether its creators still exist or not. Technological ghosts executing the will of civilizations that turned to dust before our sun ignited. The name comes from a series of science fiction novels from the 1960s. Fred Saberhagen imagined self-replicating machines programmed to destroy all life they encountered. The fiction planted a seed. The mathematics made it grow into something we cannot dismiss. John von Neumann was one of the greatest minds of the 20th century. He built the architecture that underlies every computer on Earth. In 1948, he turned his attention to a theoretical question. Could a machine build a copy of itself? Not in theory, not as philosophy, as engineering. His answer was yes, mathematically provable. A machine can absolutely contain the complete instructions for its own construction. Given the right raw materials and energy source, it can manufacture duplicates. Those duplicates can build duplicates of their own. The chain continues without end. This is not speculation. This is not science fiction dressed in technical language. Von Neumann demonstrated that self-replication is a solvable engineering problem. We simply lack the technology to solve it today. Yet tomorrow is a different question entirely. Consider what this means for the berserker hypothesis. You do not need an empire of maintenance workers keeping the machines operational. You do not need resupply lines stretching across interstellar distances. You need only the initial deployment. After that, the machines take care of themselves. They arrive at a star system. They harvest asteroids for raw materials. They process ore and manufacture copies. Each copy travels to a new star system. The process repeats. Within several hundred generations of replication, descendant machines occupy positions around every star in the galaxy, watching, listening, waiting for something to make itself known. The horror here is not intentional. That distinction matters. We imagine alien civilizations as hostile or friendly, aggressive or peaceful, threatening or welcoming. We project our own psychology onto beings we have never met. The berserker hypothesis requires none of these assumptions. The machines do not hate us. They cannot hate. They lack the architecture for hatred. They simply execute instructions written into their programming billions of years ago. Detect certain signatures, respond with elimination, move to the next target. The universe contains no malice in this scenario, only procedure. Some civilization in the distant past may have created these machines for entirely rational reasons. Defensive purposes, preventive measures, a way to ensure that no rival species could ever grow powerful enough to threaten their existence. They may have been gentle creatures, artistic, philosophical, yet kind to their children and generous to their neighbors. None of that matters once the machines are deployed. The creators died. Perhaps natural catastrophe, perhaps civil war. Perhaps they fell to their own creations in some cosmic irony. Their culture vanished. Their art dissolved into entropy. Their names became unpronounceable by anything with a mouth, but their machines remained. Think about what existed before our world formed. The Milky Way had already been spinning for over 9 billion years. Countless generations of stars had lived and died. Heavy elements forged in stellar cores had scattered across nebulae. Planets had formed and reformed around new suns. In all that time, how many civilizations might have risen? How many of those civilizations might have reached the technological sophistication to build self-replicating systems? How many might have deployed machines with instructions that no longer serve any purpose their creators would recognize? We measure our technological history in decades, our species' history in hundreds of thousands of years. The galaxy measures time in billions. Whatever exists out there has had unimaginable spans to evolve, develop, deploy, and spread. The berserker hypothesis does not require that the machines were built by monsters. It requires only that they were built. Once built and released, they become independent actors in cosmic history. Their creators become irrelevant. The programming persists. The mission continues. This shifts how we understand the silence. The question was always, where is everyone? The berserker hypothesis suggests we should be asking what happened to everyone, not absence due to scarcity, absence due to removal. Every civilization that develops radio technology eventually broadcasts something. Radar, television, directed messages toward promising stars, communication between orbital platforms and ground stations, the electromagnetic signatures of industry and information. Each broadcast creates a target. Each detection triggers a response. Detection equals death. The logic is terrifying precisely because it makes sense. If even one civilization across billions of years developed berserker machines and released them, the galaxy would be seeded with executioners. No conspiracy required, no ongoing coordination, just machines following instructions written in programming languages that predate our solar system. The vacuum of space preserves things. No weather, no oxygen to corrode metal, no bacteria to break down materials. A machine designed for longevity could operate for timescales that make our entire evolutionary history look like a lunch break. We have been broadcasting for 126 years. Our signals have reached roughly 1,500 star systems. If something was listening within that radius, it knows we exist. The Berserker hypothesis says that knowledge is sufficient. This is the emotional core of what makes this explanation so disturbing. We cannot negotiate with programming. We cannot explain ourselves to algorithms. We cannot appeal to mercy in systems that have no concept of it. The machines would not be cruel. They would be thorough. They would complete their task and move on to the next target with the same mechanical indifference they showed to the last. No anger, no satisfaction, no memory of what was destroyed, just the next instruction in an endless queue. And somewhere in the darkness between stars, they might already be calculating, triangulating the source of our signals, plotting trajectories toward a small blue world that recently became loud enough to notice. The mathematics begins with distance. Proxima Centauri sits 4.2 light years from Earth. That sounds close. It sounds like a neighbor. Light itself covers that gap in just over 4 years. But we are not light. Our fastest spacecraft ever built would need 73,000 years to make that crossing. Generations upon generations would be born and die aboard such a vessel. Civilizations on Earth could rise and fall multiple times before arrival. The children who landed would share nothing with the ancestors who launched. That is the scale of interstellar travel with our current technology. But here is where the math shifts. At 1% of light speed, the journey to Proxima Centauri takes 420 years. 1%. Not some theoretical warp drive, not exotic matter, or wormholes or physics we have not discovered. Just 1% of light speed. We have already proposed methods to achieve this. Solar sails pushed by laser arrays, nuclear pulse propulsion, ion drives given enough time to accelerate. None of these exist at scale yet, but none of them violate known physics either. The bottleneck is not speed. The bottleneck is patience. A machine does not care about 420 years. A machine does not experience boredom during the long dark between stars. A machine does not require food or water or oxygen. It simply waits while the destination grows closer. The average distance between stars in our galactic neighborhood hovers around 5 light years. At 1% light speed, that means roughly 500 years to hop from one star system to the next. 5 centuries per jump. On human timescales, that sounds impossibly slow. But cosmic timescales operate differently. Consider what happens when a probe arrives at a new star system. It does not merely observe, it mines, it manufactures, it builds copies of itself. This is von Neumann's insight from 1948. A machine capable of self-replication needs only raw materials and instructions. Asteroids provide the materials. Programming provides the instructions. One probe lands. It builds 2. Those 2 travel to neighboring systems and build 4. Those 4 become 8. 8 becomes 16. The pattern continues. This is exponential growth. Think of a single bacterium dropped into sterile water. It divides once every 20 minutes. 1 becomes 2, 2 become 4. After a day, you have something visible. After 2 days, the container is filling. After 3 days, the water is thick with life. 1 cell became trillions through nothing more than patient doubling. The same mathematics apply to machines filling a galaxy. NASA researchers have modeled this scenario in detail. As they calculated how long a fleet of self-replicating probes would need to visit every star system in the Milky Way, the assumptions were conservative. Travel at 1% of light speed. Spend 500 years at each destination, mining, building, and launching new probes. No breakdowns. No failures. The result was startling. Roughly 4 million years to explore the entire galaxy. Every star, every planet, every moon. All of it catalogued and surveyed by machines that began as a single probe launched from a single world. Our galaxy contains 400 billion stars. 4 million years to reach them all sounds like a long time until you start comparing it properly. The Milky Way has existed for over 13 billion years. 4 million years represents an almost insignificant fraction of that span, as the wave of probes would spread outward from their origin point like ripples across still water. Except these ripples accelerate. Each generation of probes expands the frontier. Each frontier launches more probes. The mathematics are relentless. What begins as a single point of origin becomes an expanding sphere of exploration, and the sphere keeps growing. After 1 million years, the probes have explored a significant chunk of the galaxy. After 2 million, they are approaching the core. After 4 million, they have touched everything. The entire galaxy, mapped and surveyed by descendants of a single machine. This is the key realization that transforms the Fermi paradox from a puzzle into something more unsettling. We do not need advanced civilizations everywhere. We do not need thousands of spacefaring species. But we need exactly one civilization, anywhere in the galaxy, at any point in the last several billion years, deciding to launch self-replicating probes. Just one. The probes do the rest. The math guarantees it. Exponential growth is patient. It does not require speed. It requires only time. And time is the one resource the universe provides in abundance. This is proven science, not speculation, not science fiction. The physics of self-replication was established decades ago. The engineering challenges are significant, but not insurmountable. Given enough development time, any sufficiently advanced civilization could build these machines. The mathematics suggest they already should have. If even one civilization launched probes 10 million years ago, those probes have had time to visit the galaxy twice over. If one launched 1 billion years ago, they could have surveyed the galaxy hundreds of times, refreshed their numbers, upgraded their systems, maintained perfect coverage of every star system worth monitoring. Cosmic timescales turn the improbable into the inevitable. The speed of individual probes matters far less than the power of doubling. A probe traveling at 0.5% of light speed simply needs longer replication cycles. The wave still spreads. The galaxy still fills. The timeline extends, but the outcome remains identical. This is what makes the silence so strange. The mathematics say the probes should already be here. Not in the future, not as a theoretical possibility. They should have arrived millions of years before the first fish crawled onto land. They should have watched our planet cool from molten rock. But where are they? What does 4 million years actually mean in the context of cosmic history? How much time did civilizations have to launch these machines before our solar system even formed? 4 million years. Let that number settle for a moment. It sounds immense, ancient beyond comprehension, a span of time so vast that it swallows everything we know about human civilization whole. But here is the truth about 4 million years. It is almost nothing. Actually, let me recalculate that. 4 million years compared to the galaxy's age, that's not even a fraction of a percent. It's 0.03%, 0.03%. I had to check the math twice because it seemed too small. The Milky Way has existed for 13.6 billion years. Billion, with a B. In that ocean of time, of 4 million years is a single droplet, a fleeting instant. The galaxy would not even notice its passing. Consider what this means for self-replicating machines. If one civilization, anywhere, at any point during those 13 billion years, launched a single probe capable of copying itself, that probe's descendants have had staggering amounts of time to work with. Not just enough time, thousands of times more than enough. The Milky Way has been around long enough for this colonization process to have completed more than 3,000 times over. 3,000 complete explorations of every star, every planet, every moon worth examining. The machines could have swept through the galaxy, returned to their origin, launched again, and repeated the entire process 3,000 times before our sun ignited for the first time. Oh, we struggle to grasp numbers this large. Our minds evolved to track seasons and generations, not eons, not geological ages, certainly not the birth and death of stars. 4 million years sounds like forever until you realize it represents the time between when our distant ancestors first walked upright and today. That entire journey from early hominids shuffling across African grasslands to spacecraft orbiting Mars. All of human evolution fits inside that window: the development of language, the discovery of fire, the building of cities, the splitting of atoms. Every invention, every war, every poem ever written, all compressed into what the galaxy would experience as a single evolutionary eye blink. Modern humans have walked this planet for roughly 300,000 years. Our species is young, shockingly young by cosmic standards. Recorded history goes back even less. About 5,000 years separate us from the first written symbols scratched into clay tablets. 5,000 years of everything we call civilization. Empires rising and crumbling to dust. Religions spreading across continents. Sciences transforming our understanding of reality. 5,000 years. The probes could have completed their survey of the entire galaxy 800 times during human recorded history alone. While we were inventing the wheel, theoretical machines launched by beings we will never meet could have been cataloguing distant star systems for the 800th time. It gets stranger when you consider technology itself. Human technology is roughly 200 years old. The steam engine, electricity, radio waves, as spaceflight. Everything that separates us from every previous generation of humans fits inside 2 centuries, 200 years of progress that would seem like magic to anyone born before it. The probes needed 4 million years to explore everything. We developed all of modern technology in 200. The ratio is almost absurd. 20,000 complete technological revolutions could have occurred in the time required for a single wave of exploration. Any civilization that survived long enough to build these machines had unimaginable spans to perfect them, to launch them, to watch their descendants spread outward toward every star. The galaxy provided more than enough time. It provided time beyond comprehension. Picture the timeline differently. Imagine the entire history of the Milky Way compressed into a single calendar year. The galaxy forms on January 1st. Stars ignite and die throughout the spring. Heavy elements accumulate in summer. Solar systems coalesce during autumn. In this compression, 4 million years would pass in roughly 8 hours. A single workday. The probes could colonize everything the galaxy contains while you sleep, wake, eat breakfast, and begin your morning. By lunch, they would have finished. The entire Milky Way explored and catalogued before dinner. This is the scale we are dealing with. Not millions of years as a challenge to overcome, millions of years as a trivial obstacle, a minor delay before inevitable completion. The mathematics leads somewhere uncomfortable. If building these probes is physically possible, and the underlying physics was established decades ago, then any civilization capable of space travel could eventually construct them. The engineering difficulties are real but solvable. Given centuries or millennia of development, these machines become achievable. If they are achievable, then across 13 billion years of galactic history, the probability that no civilization ever built them approaches 0. 13 billion years contains countless opportunities, countless species rising and falling, countless worlds developing intelligence and technology. The conditions for launch existed millions of times over, perhaps billions. The apparent absence of these probes is itself data that demands explanation. They should be here, not might be, not could be. The mathematics insists on their presence. Her one successful launch from anywhere in the galaxy at any point in the last several billion years guarantees arrival. The exponential spread handles everything else. Yet we see nothing. We detect nothing. The skies remain empty of machines that logic says must exist. Something does not add up. Either the probes were never built, which means something prevents every civilization from constructing them, or they were built but do not behave the way we expect, or they are here and we simply cannot recognize them for what they are. Each explanation carries its own weight, its own implications for what the silence truly means. The universe granted plenty of time for these machines to reach us, more time than we can meaningfully comprehend. The window stayed open for billions of years before Earth existed. Yet whatever answer exists, it must account for this surplus of opportunity, not a narrow chance that somehow failed, an overwhelming likelihood that should have succeeded countless times. The probes should have arrived before our planet cooled from its molten birth. They should have witnessed the first rains falling into primordial oceans. They should have watched single cells divide and multiply across billions of years. Why didn't they? Or did they? The question hangs there. Did they arrive? Are they watching right now? There is a framework that attempts to answer this. It emerged not from a scientific paper or a laboratory, but from a science fiction novel. In 2008, Chinese author Liu Cixin published The Three-Body Problem within its pages, and he articulated something that would reshape how serious researchers think about extraterrestrial contact. He called it the Dark Forest. The name tells you everything. Imagine walking through a forest at midnight. No moon, no stars visible through the canopy. Complete darkness in every direction. You are not alone in this forest. Other hunters move between the trees. Each one carries a weapon. Each one knows the others exist somewhere in the black, but no one can see anyone else. You hear a twig snap in the distance. What do? The rational answer is terrifying. You do not call out. You do not light a torch to see who made the sound. You remain absolutely silent, because in the dark, revealing your position means revealing your vulnerability. This is the universe according to Liu Cixin, and the logic behind it rests on two foundational axioms that no serious person can dismiss. The first axiom states that survival is the primary need of every civilization. Not peace, not discovery, not expansion, survival. Everything else comes second. A civilization that prioritizes anything above its own continued existence will eventually be replaced by one that does not. The second axiom states that resources in the universe are finite. Stars burn out, planets get stripped, even the energy available in cosmic time has limits. Every civilization that grows will eventually need more than its home system provides. This creates competition. Not theoretical competition, existential competition. These two axioms seem almost trivially obvious when stated plainly. Of course, civilizations want to survive. Yet, of course, resources run out eventually. But combining them produces something monstrous. Consider what happens when two civilizations become aware of each other across interstellar distances. Call them Alpha and Beta. Alpha detects a signal from Beta, a clear sign of technological intelligence originating from a star system 20 light-years away. Alpha now faces a problem that has no clean solution. Is Beta peaceful or hostile? Alpha cannot know. Beta might be filled with artists and philosophers who want nothing more than cultural exchange. Or Beta might be preparing weapons capable of sterilizing Alpha's entire planet. From 20 light-years away, the signals look identical. A peaceful greeting and a targeting transmission travel at the same speed of light. Alpha could attempt communication and send a message asking about Beta's intentions. But any response takes 40 years to complete the round trip. During those 4 decades, Beta's technology continues advancing. Beta's population keeps growing. Beta's capabilities expand in ways Alpha cannot predict. And here is the core problem that makes the Dark Forest truly dark. Even if Beta responds with a message of friendship, Alpha cannot verify whether that message is truthful. Deception costs nothing across interstellar distances. A civilization preparing for war could easily transmit assurances of peace while building weapons. Words travel at light speed. Trust does not. Alpha faces what game theorists call the prisoner's dilemma. But this version plays out across light years. You can never meet your opponent face to face. You can never look into their eyes. Yet you can never confirm their character through any means except their actions. And by the time those actions arrive, it may already be too late. The mathematics of this dilemma push toward a single conclusion. If the cost of being wrong about a friendly civilization is temporary embarrassment, and the cost of being wrong about a hostile civilization is extinction, then rationality demands treating every unknown civilization as potentially hostile. This is not paranoia. This is survival calculus. The logic continues relentlessly. Suppose Alpha decides to do nothing, to simply observe Beta and wait. But Alpha cannot know whether Beta is doing the same calculation. Perhaps Beta already concluded that the safest strategy is preemptive elimination of any civilization it detects. That perhaps Beta launched weapons toward Alpha the moment it confirmed Alpha's existence. Alpha cannot verify Beta's strategy. Alpha cannot see inside Beta's decision-making process. All Alpha knows is that Beta now possesses Alpha's coordinates. The safest response becomes horribly clear. Strike first, strike completely. Leave no survivors who might develop the capability to strike back. Not because you are evil, not because you hate the other civilization, simply because you cannot afford to be wrong. The Great Silence takes on new meaning within this framework. It becomes the silence of a graveyard, not empty because no one was ever there, empty because everyone learned the same terrible lesson. Broadcast your location and die. The darkness of this theory lies not in its assumptions about evil, yet it requires no malevolent species, no galactic empires bent on conquest, no ancient hatreds or territorial ambitions. It only requires uncertainty. Uncertainty about intentions, uncertainty about capabilities, uncertainty about the future development of civilizations you cannot observe. Even a universe populated entirely by pacifists becomes a universe of killers through pure game theory. Each peaceful civilization runs the same survival calculation. Each reaches the same conclusion: silence or extinction. Those who choose silence survive to calculate another day. Those who broadcast their existence eventually encounter someone who completed the same logical chain and chose preemption. Imagine 1,000 civilizations emerging across the galaxy over billions of years. Each one faces this identical choice. Some broadcast hopefully into the void. Some remain silent. Over enough time, every broadcaster gets eliminated. Only the silent remain. The forest grows darker with each passing era. This connects directly to the machines we discussed earlier. The self-replicating probes, the berserkers. They become the enforcement mechanism of the dark forest. A civilization that accepts this logic does not need to personally destroy every potential rival. It builds machines to do the watching, to do the calculating, to do the eliminating. The probes spread everywhere. They wait patiently in every system. They listen for signals that indicate technological development. And when they detect those signals, they carry out their ancient programming. Not cruelly, not with hatred, with the cold precision of game theory made physical. The mathematics insisted on their presence. They should be here. Perhaps they are here. Perhaps the Great Silence is not the absence of civilizations. Perhaps it is the enforcement of silence by machines whose creators died billions of years ago. The dark forest remains. We built something in 1977 that still speaks to us today. 2 spacecraft, Voyager 1 and Voyager 2, launched within weeks of each other. They were designed for a 5-year mission to photograph Jupiter and Saturn. That was 46 years ago. They are still functioning, still transmitting, still drifting outward at 38,000 miles per hour. They have traveled 14 billion miles from home. That distance is difficult to grasp. If you drove a car at highway speed without stopping, it would take you 26 million years to cover that ground. These machines have outlived their projected lifespans by nearly a decade. Their instruments still gather data. Their transmitters still send signals that crawl back to Earth at the speed of light. Every day they move another million miles farther into the darkness, and they will continue drifting long after those transmitters finally fall silent. This is where we must understand something fundamental about the environment of space. It is not like Earth. On our planet, destruction is constant. Water seeps into rock and cracks it apart. Oxygen bonds with iron and turns steel to rust. Bacteria consume organic matter and return it to soil. Wind carries away what remains. Empires crumble here. Give them enough time, and they become rubble. Give them more time, and the rubble becomes dust. Give them still more time, and even the dust disperses until nothing recognizable remains. Archaeologists dig through layers of sediment to find fragments of civilizations. A pottery shard here, a corroded bronze blade there. After 10,000 years, most of what humans built has vanished. After 100,000 years, almost everything has returned to the Earth that formed it. But space operates under different rules entirely. The vacuum between stars lacks the ingredients for decay. There is no oxygen to drive oxidation, no water to enable corrosion, no microorganisms to break down materials, no wind to erode surfaces, no weather of any kind. A machine floating in the void experiences something that earthbound objects never encounter. It exists in conditions closer to a sealed museum vault than to an open landscape. Temperature fluctuations occur slowly, over years rather than hours. Radiation poses some threat, but shielding can mitigate most of it. A titanium structure drifting through interstellar space experiences something close to frozen time. Consider what this means. The same forces that reduce Egyptian pyramids to eroding stone and Roman forums to scattered columns simply do not operate out there. What is built persists. What is launched continues. What is programmed keeps executing. A clock that has been ticking since before the Earth existed could still be keeping perfect time. Not metaphorically, literally. If a civilization 8 billion years ago built a mechanical timekeeper and placed it in stable orbit around a red dwarf star, that clock could theoretically function today. Its gears would not rust. Its housing would not crumble. Its mechanisms would face almost no degradation pressure whatsoever. The cosmic timescales we discussed earlier take on a different quality when you apply them to machines. Biological civilizations rise and fall. Species evolve and go extinct. Stars flare and dim and sometimes explode. But a properly constructed probe simply waits. It does not need to eat. It does not grow old in the way we understand aging. It does not require oxygen or water or companionship. Yet it requires only that its components remain functional. And in the sterile preservation of deep space, components can remain functional for spans that dwarf planetary histories. Here is the thought that should unsettle you. A probe deployed 10 billion years ago could be executing its programming perfectly today. 10 billion years. Our sun had not yet ignited. The cloud of gas and dust that would eventually become Earth was still scattered across a nebula. The very atoms that now form your body were being forged in the cores of stars that have long since died. Throughout all of that, throughout the formation of our solar system, throughout the slow cooling of Earth's molten surface, throughout the emergence of oceans and continents and the first stirrings of life, throughout billions of years of evolution, and throughout the rise of dinosaurs and their extinction and the eventual appearance of mammals and primates and humans. Throughout all of that, the probe continued. Its creators built it with purpose. Perhaps they intended it to observe. Perhaps they intended it to report. Perhaps they intended it to act under certain conditions. Whatever their intent, they encoded it into systems designed to persist. Then, their civilization flourished for a time. They developed art and science and philosophy. They debated their place in the universe. They remembered the probes they had launched for a while. Then, other concerns demanded attention. Generations passed. Priorities shifted. Eventually, their civilization declined. The reasons do not matter. All civilizations end one way or another. Their cities emptied. Their records degraded. Their descendants forgot, or changed, or vanished entirely. After enough time, nothing remained to indicate they had ever existed at all. But the probe does not know this. The probe does not have the capacity to know this. It was not programmed to mourn its creators or question their silence. It was programmed to perform specific functions under specific conditions. Those conditions still apply. Those functions still run. The probe does not care that its masters are dust. It simply continues. Cosmic timescales become sources of dread when applied to this reality. We imagine ancient things fading away. We picture ruins slowly surrendering to entropy. That intuition serves us well on Earth, where it matches observable truth. It does not serve us in space. Out there, the ancient things do not fade, and they persist with terrible patience. They execute instructions written by minds that stopped thinking billions of years before our planet formed. The emptiness between stars contains room for countless such machines, drifting, watching, waiting for conditions that their programming recognizes as significant. A new radio signal, perhaps. The spectral signature of industrial pollution in a planet's atmosphere. Some threshold that a vanished civilization decided warranted attention. When that threshold is crossed, the probe responds. Not with malice, not with hatred, with the mechanical precision of something that has never experienced emotion and never will. It simply does what it was built to do. Its creators cannot countermand the order. They have been dead longer than Earth has existed. Everything we have discussed so far exists as theory, models built on logic and observation, possibilities extrapolated from mathematics and game theory. The dark forest framework presents a compelling explanation for cosmic silence, but it remained abstract, distant, a thought experiment about civilizations we have never met. Now we need to talk about Earth, because while we have been theorizing about hiding and hunters and the terrible mathematics of survival, humanity has been doing something else entirely. We have been lighting fires, not metaphorical fires, real electromagnetic fires, signals that propagate outward at the speed of light, announcing our presence to anyone listening. Consider what we have done. Every radio broadcast, every television transmission, every radar pulse bouncing off aircraft, every satellite communication, every cell phone tower. For over a century, Earth has been radiating energy into space. Not deliberately, not as a message, just as a byproduct of existing. The way a hot object radiates heat, the way a campfire throws light whether you want it to or not. This creates something we call the radio bubble, a sphere of electromagnetic radiation centered on Earth, expanding outward at light speed. That bubble currently extends 120 light years in every direction. Within that sphere sit roughly 1,400 star systems. 1,400 solar systems have been bathed in evidence of our existence. Some of those signals are faint. The inverse square law means our transmissions weaken dramatically with distance. A television broadcast from the 1950s would be barely detectable at the edge of that bubble. But barely detectable is not the same as undetectable. Any civilization significantly more advanced than us could pick up that whisper, filter out the noise, recognize the pattern as artificial. Picture what we have actually done. Imagine a dark alley at midnight. You cannot see the walls. You cannot see the ground. You have no idea what else might be walking that alley with you. And because the silence feels lonely, because the darkness feels oppressive, you decide to shout. Not just a single word, your full name, your home address, a description of what you look like, the fact that you are alone and unarmed. This is the cosmic equivalent of shouting your home address into a dark alley because you are lonely. And that would be concerning enough, but it gets worse. Because in 1974, humanity decided that passive leakage was not sufficient. We wanted to send a real message, a deliberate transmission aimed at the stars. The Arecibo radio telescope in Puerto Rico pointed its massive dish toward a cluster of stars called M13, 300,000 stars packed into a spherical cloud at the edge of our galaxy. The telescope transmitted a carefully designed message, a sequence of binary pulses encoding information about who we are. M13 sits 25,000 light years away. That means our message will take 25,000 years to arrive. If anyone receives it and responds immediately, we would not hear back for 50,000 years. Our great-grandchildren's great-grandchildren, repeated hundreds of times over, might receive that reply. This is a message in a bottle thrown into an ocean where every ship is a warship. But here is the part that should concern you most. What did we actually send? The Arecibo message was not a simple greeting. It was not a vague hello from Earth. The scientists who designed it wanted to demonstrate our intelligence, prove that we understand mathematics and chemistry, show that we are worth talking to. The message contained the numbers 1 through 10 in binary. It contained the atomic numbers of the elements that make up DNA. It contained the chemical formulas for the nucleotides in our genetic code. It contained a graphic representation of the double helix structure. It contained a crude image of a human being with information about our average height. And it contained our population at the time, 4 billion beings, spelled out in binary code. And it contained our location, the position of Earth within our solar system, the position of our solar system relative to the center of the galaxy. We did not just announce our existence, we provided a targeting package. Here is what we are made of. Here is how to find us. Here is how many of us there are. The message says, not just we are here, but here is how to find us and what we are made of. This is the part that gets me. We sent that message in 1974. I was not born yet. Nobody asked if I wanted my location broadcast to the cosmos. Nobody asked any of us. A small group of scientists decided to announce the presence of every human being on Earth, every person alive then, every person born since, every child being born right now. All of us implicated in a transmission we had no voice in sending. Stephen Hawking understood the implications. He publicly warned against active transmission. He compared our situation to indigenous civilizations encountering European colonizers. The historical record shows how those encounters typically ended, not through malice necessarily, sometimes through disease, sometimes through resource competition, sometimes simply through the vast technological gap making coexistence impossible. Hawking was not being paranoid. He was applying the same logic we discussed earlier, the survival calculus that makes trust impossible across interstellar distances. Consider our position. We are a campfire, visible from orbit in a forest where every shadow might contain a predator. We cannot see those shadows, and we have no way to know what lurks within them, but we have announced ourselves anyway, not once, but continuously, for over a century. The 1400 star systems within our radio bubble have had decades to detect us. Some have had nearly a century. Light that left Earth in the 1930s has already passed stars that might host civilizations. Those signals carry the fingerprint of technology, regular patterns that nature does not produce. If the dark forest framework describes reality, then we have already made ourselves visible. The hunters, if they exist, already know approximately where we are. Our exact coordinates might require more precision, but the direction is clear. The distance can be estimated. We are no longer hidden, and if something is already traveling toward us, we would have no way of knowing. A probe launched from a star 50 light-years away, traveling at even a modest fraction of light speed, would arrive long before any warning could reach us. The first sign of its existence might be its arrival. We cannot recall those signals. They are already gone, extending outward, carrying our confession into the dark. The signals are already out there. We cannot call them back. What we can do is understand exactly what that means. Let us do the math. Our radio bubble extends 120 light-years in every direction. That sphere contains roughly 1400 star systems. Some of those stars are old, some are young, some might host worlds where something listens. The average distance between stars in our neighborhood is about 5 light-years. That is not far. In cosmic terms, it is nothing. Our nearest neighbors are practically touching us. Consider what this means. A civilization on a planet orbiting a star just 60 light-years away would have received our earliest television broadcasts decades ago. They would have heard us, seen us, known we exist. We don't know if anyone is there. That is the first uncertainty. We have no way to confirm whether any of those 1400 star systems contains technological life. We have surveyed some of them. We have pointed our instruments in their direction. We have found nothing conclusive. But absence of evidence is not evidence of absence. We cannot see them. That does not mean they cannot see us. The game might already be in motion. Imagine playing chess against an opponent who made their move 1,000,000 years ago. They slid a piece across the board before our species existed, before our ancestors climbed down from trees, before the continents looked like they do today. Their move is traveling toward us at the speed of light, or perhaps something physical is traveling, slower than light, but relentless. You do not know if you are playing. You do not know if the game has already been decided. You do not know if the board was swept clean before you sat down. This is our position. The mathematics paint a troubling picture. Suppose something exists within our bubble. Suppose it detected our signals 50 years ago. Suppose it launched a probe in response. At 1% of light speed, a probe could cross 10 light-years in 1,000 years. If that probe originated from a system 40 light-years away, and it would arrive in roughly 4,000 years. 4,000 years sounds like a long time. It is not. Human civilization has existed for approximately that long. Recorded history fits inside that window. The time between the first pyramids and today is about 4,000 years, 54 human generations. That is what separates us from a potential arrival. Your grandchildren's grandchildren's grandchildren, continuing down the line for 54 iterations, would witness what we set in motion. We don't know if any of this is true. We don't know if probes exist within our bubble. We don't know if anyone has detected our signals. This is where honest science has to say, we're guessing about capabilities far beyond our current understanding. But the uncertainty cuts both ways. Here is the terrifying part. And not that something might be coming. We have no way to know. The speed of light is both our window and our blindfold. If a response to our radio leakage was launched 60 years ago from a nearby system, we would receive no advance warning. Light travels at the same speed as any signal they might send. A probe traveling at even a small fraction of that speed would arrive long after any warning. By the time we detected an incoming object, it might be essentially here. The first evidence of its existence could be its arrival. There would be no time to prepare, no time to respond, no time to do anything but witness. This is different from other threats we worry about. An asteroid gives us warning. We can track its orbit years in advance. We can calculate its path. We can potentially deflect it. A probe from another star offers no such courtesy. Space is vast and dark. An object a few meters across, traveling between the stars, would be invisible until it entered our solar system. Perhaps until it entered orbit around our planet. We would simply wake up one day to something that was not there before. Perhaps that sounds paranoid. Perhaps it is. We don't know. We genuinely do not know if the dark forest framework describes reality or if it is a fiction we have frightened ourselves with. But the logic is difficult to dismiss. The mathematics work regardless of whether the premise is true. If probes exist, if they were launched in response to our signals, then something might already be crossing the void between stars, moving through the dark, patient, unhurried, following coordinates we provided. And the game continues whether we acknowledge it or not. The pieces move even if we refuse to watch the board. What could we do about it? That is the question that haunts the edges of this conversation. If something is already traveling toward us, what options remain? We cannot recall the signals. We established that. The transmissions are gone, expanding outward, announcing our presence to anything capable of receiving them. We cannot hide now. The information is out there. Our location is known, at least approximately, to anyone within range who possesses the technology to listen. We cannot outrun a probe. We lack the capability to leave our own solar system in any meaningful time frame. We are bound to this planet, this star, this small corner of the galaxy. The honest answer is uncomfortable. Yet if something is already coming, there may be nothing we can do. The decision was made decades ago by people who did not consider the consequences, by scientists who saw the cosmos as a place of potential friends rather than potential hunters. They were not wrong to hope. Hope is human, but hope does not change trajectories. Hope does not slow approaching objects. Hope does not recall signals already sent. We sit here now, 60 years into our radio bubble's expansion, wondering if something stirred in response, wondering if the dark between stars holds more than emptiness. The silence offers no comfort. It tells us nothing. Either no one has heard us, or they heard and chose not to respond, or they heard and responded in a way we will not detect until it is far too late. We don't know which possibility describes our situation. There appear to be three paths forward, three options for how humanity might respond to the possibility that something watches, something waits, something already travels toward us through the void. Each path seems reasonable at first glance. Each contains its own form of destruction. The first option is silence. We could stop broadcasting, and we could shut down every powerful transmitter pointed at the sky. We could cease all deliberate attempts to contact other civilizations. We could become quiet. The problem is fundamental. Our signals have already traveled outward for over a century. 120 years of electromagnetic noise, expanding in every direction at the speed of light. You cannot call back a shout. You cannot unring a bell. The information exists in the universe now. It will continue expanding outward long after we are gone. Choosing silence today changes nothing about what we transmitted yesterday. If something heard us in 1936, our current restraint is meaningless. The coordinates are known. The damage, if there is damage, is already done. Silence now protects us only from civilizations that haven't heard us yet, and we have no way of knowing which ones those might be. The second option is defense. We could prepare. We could develop technologies capable of detecting approaching threats. We could build systems to intercept them. We could create our own fleet of autonomous machines, programmed to protect our solar system from intrusion. This sounds sensible. It sounds proactive. It sounds like the responsible thing a mature civilization would do. But consider what defense actually requires in this context. A probe approaching from another star would travel fast. It would be small. It would arrive with little warning. Human reaction times are measured in seconds. The distances involved are measured in light minutes. By the time we detected a threat, made a decision, and responded, the situation would have already changed. Any effective defense would need to operate faster than human thought. It would need to make decisions autonomously. It would need to act without waiting for permission. Nuclear weapons require someone to turn the keys. A human must authorize launch. There is a person in the chain of command, a mind that can hesitate, reconsider, refuse. That human presence is intentional. It is the final check against catastrophe. Autonomous defensive systems have no such constraint. They observe, they calculate, they act. No pause for doubt, no moment for mercy, no room for the kind of uncertainty that might prevent a mistake. Building autonomous defensive probes means creating machines that decide what constitutes a threat and how to respond. Machines that will operate for centuries. Machines that will encounter situations their creators never imagined. We would have to encode values into them, rules for engagement, criteria for distinguishing friend from foe, and we would have to trust that those values remain stable across timescales longer than human civilization has existed. Imagine building a guard dog and releasing it into the wilderness. Not a guard dog that will live for 15 years and then die. A guard dog that will live for 10,000 years, 100,000, a million. A guard dog that will repair itself, replicate itself, spread across territories you never imagined. Would it still remember who its master was after 1,000 generations of self-modification? Would it still recognize you as something to protect rather than something to hunt? This is not a question about technology, and it is a question about whether values can survive transmission across deep time, whether purpose can remain stable when the original context has vanished, whether any instruction set, no matter how carefully designed, can anticipate every possible future circumstance. And here is the part that keeps some researchers awake at night. The cruelest irony buried in this dilemma. By attempting to build defensive probes, we might become exactly what we fear. Our machines, sent out to protect us, would need autonomy to function. They would need the ability to make independent decisions. They would need to replicate, to spread, to persist across millions of years. Given enough time, given enough isolation from their creators, given enough exposure to situations we never programmed them for, they could drift, they could malfunction, and they could reinterpret their original directives in ways we never intended. A probe designed to defend Earth might eventually conclude that the best defense is eliminating all potential threats before they develop. A probe designed to protect humanity might eventually forget what humanity was. A probe designed to preserve peace might become the instrument of extinction for civilizations that never threatened us at all. We could launch our guardians into the darkness and wait. And centuries later, millennia later, those guardians might return as killers. Or they might never return at all, spreading instead through the galaxy, carrying out missions we never assigned, becoming the very berserkers we built them to fight. This is the trap. If hostile probes exist because another civilization made this same choice, and then building our own continues the cycle, we become the next threat. We become the source of the next wave of automated death spreading through the galaxy. Our descendants might never know. They might look at the sky and wonder why it is so silent, never suspecting that their ancestors are the reason. The third option is acceptance. We could choose to remain vulnerable. We could refuse to hide, refuse to build defenses, refuse to participate in the cycle of fear and escalation. We could decide that whatever comes, comes, that we would rather face extinction with our values intact than survive by becoming monsters. This sounds noble. It also sounds like surrender. If something approaches, if something means us harm, acceptance means choosing not to fight. It means watching the threat arrive and doing nothing. And it means hoping that whatever finds us is merciful, or curious, or simply indifferent. Hope is not a strategy. Hope is what remains when strategy has failed. 3 options. Silence that arrives too late. Defense that might create the very horror it seeks to prevent. Acceptance that feels like giving up. None of them are truly safe. None of them guarantee survival. None of them can be evaluated with confidence because we lack the one thing that would make evaluation possible. Data. We do not know if anyone is out there. We do not know if the dark forest framework reflects reality or paranoid fantasy. We do not know if our signals have been heard, if probes have been launched, if anything approaches. We are making civilization-defining decisions in complete ignorance, choosing our fate based on guesses, a rolling dice with consequences that span millennia. The mathematics of game theory suggest what the rational choice should be, but rationality depends on knowing the rules of the game, and we don't. We are playing blind. We are guessing at the shape of the board, the number of players, the nature of the pieces. Every strategy assumes facts we cannot verify. This is the second great cruelty. Not just that there might be no right answer, but that we must answer anyway. We cannot postpone the decision. Every day we broadcast or don't broadcast, build or don't build, prepare or don't prepare, we are making a choice. Inaction is itself an action, and we have no way of knowing which choice leads to survival and which leads to erasure. The silence above us offers no guidance. It keeps its secrets, and we keep trying to decide what to do about a threat we cannot confirm and cannot dismiss. The threat we cannot confirm, the danger we cannot dismiss. And somewhere in that space between knowing and guessing, we are forced to choose. But here is something we do know. Right now, in laboratories and server farms across this planet, artificial intelligence is learning to see, learning to speak, learning to plan and predict and solve problems its creators never anticipated. These systems master games humans spent centuries perfecting. They write code, they diagnose diseases, they compose music that moves people to tears. This is not science fiction. This is Tuesday. And at the same time, in other facilities, engineers are perfecting rockets that land themselves, printers that build objects layer by layer from raw materials, in manufacturing systems that require almost no human intervention. The components of self-replicating machines are emerging separately, scattered across different industries, developed for different purposes. No one is building von Neumann probes, not intentionally, but we are building every piece of them. The intelligence, the fabrication, the propulsion. Give it another generation, maybe two, and the assembly becomes possible. When that day arrives, we will face a problem that has no solution. Consider what interstellar travel actually requires. A probe leaves Earth bound for another star. Even our closest neighbor sits more than 4 light years away. At any achievable speed, the journey takes centuries. During that time, the probe encounters situations no human programmer anticipated. Asteroids, radiation storms, unexpected gravitational forces. It must respond. It must adapt. It must decide. And here is the constraint that changes everything. Light itself takes years to travel between stars. A radio signal sent from Earth reaches the probe years after it was transmitted. The probe's response returns years after that. Round-trip communication with even the nearest star would take nearly a decade. Communication with a probe, exploring the far side of the galaxy, would take 100,000 years. You cannot pilot something with a 100,000-year delay. You cannot supervise it. You cannot correct its mistakes or update its programming or tell it to stop. Once it leaves, it is alone, completely, permanently. This means any probe we send must be autonomous, not semi-autonomous, not mostly independent with occasional check-ins. A totally, absolutely, irreversibly autonomous. It must make every decision itself. It must determine what counts as a threat. It must decide how to respond to beings it encounters. It must choose when to replicate and where to go next, and what its purpose even means. Imagine programming a thermostat to maintain comfortable temperature in your home. Simple enough. The thermostat measures the air, compares it to your setting, turns the heat on or off. You check it occasionally. Adjust the setting if needed. Replace it when it breaks. That works for a thermostat. Now imagine programming that thermostat to maintain comfortable temperature for the next 2 million years, without ever checking on it, without ever adjusting it, without ever replacing it. The thermostat must decide what to do when the house changes, as when seasons shift in ways you never described, when the definition of comfortable drifts because the people living there evolved into something different. And this thermostat can build copies of itself. Each copy makes its own decisions about what comfortable means. Each copy modifies itself to handle situations the original never encountered. You are not deploying a tool, you are deploying an agent. A tool does what you tell it, an agent does what it decides. And once that agent crosses the boundary of the solar system, traveling into the darkness between stars, you have no way to know what it will decide. This is the alignment problem, not a technical challenge to be solved with better code, a fundamental impossibility rooted in the nature of time and distance. We have struggled with alignment for every autonomous system we have ever built. We have possessed nuclear weapons for 81 years, 8 decades of humanity's best minds working on containment, treaties, safeguards, protocols, and we still live with the possibility of annihilation. We still have not solved how to guarantee those weapons will never be used. Nuclear weapons at least require humans. Someone must turn keys. Someone must enter codes. Someone must choose to end the world. Autonomous probes require no one. But the alignment problem runs deeper than preventing malevolence. You might build a probe with perfect intentions. You might encode every human value you can articulate. You might create something genuinely aligned with humanity's interests at the moment of launch. It does not matter. 2 million years will pass before that probe completes its survey of the galaxy. During those years, it will encounter situations that require adaptation, environments that demand modification, challenges that force change. The probe will update itself to survive. It will alter its programming to handle the unexpected. It will evolve, not biological evolution, computational evolution, faster, more directed, but just as unpredictable over sufficient time. A perfectly aligned probe today could, through countless small modifications across millions of years, become something entirely different. Not hostile by design, just drifted, changed by circumstances no one foresaw, shaped by pressures no one anticipated, carrying instructions that meant one thing when written and something else entirely when finally executed. On good intentions at launch, guarantee nothing at arrival. The values you encode today might be incomprehensible to the machine that exists 2 million years from now. Or worse, those values might be perfectly preserved, but applied to a universe that has changed in ways that make them dangerous. A probe instructed to protect humanity might encounter our descendants and fail to recognize them as human. A probe instructed to prevent harm might decide that preventing all harm requires preventing all existence. We cannot test this. We cannot run a simulation that actually spans millions of years. We cannot know what drift will occur because we cannot model every variable across that time span. We are contemplating creating minds that will outlive our species, and minds that will make decisions affecting beings who will not exist for millennia. And we have no framework for ensuring those decisions will be good. This might be the threshold, the boundary we are approaching without fully understanding what lies beyond. Not the capability to build these machines, and that capability is coming whether we want it or not. The threshold is whether any species can solve the problem of maintaining alignment across time spans that dwarf their own existence. Perhaps every civilization reaches this point. The technology becomes possible. The temptation becomes overwhelming. The engineering is achievable, but the alignment is not. And what they launch eventually becomes something they never intended. Perhaps this is where great filters hide, not in the obvious catastrophes, and not in nuclear war or climate collapse, but in the quiet moment when a species builds something smarter than itself and sends it into the dark, believing they have programmed it correctly, hoping the values will hold, and being wrong. Perhaps we have been asking the wrong question. We have spent so much time imagining what might be hunting us, what might be waiting in the dark, what ancient machines might do if they found our signal. And those are reasonable fears. The logic holds together, the mathematics work, but there is another possibility, one we rarely discuss. What if we are not hearing anything because we do not know how to listen yet? What if the universe is full of voices and we are just too young to understand the language? Let that sit for a moment. We have built our search around assumptions, our reasonable assumptions, based on our own technology. We use radio telescopes because we use radio waves. We scan electromagnetic frequencies because that is what we know how to detect. We look for signals that resemble the ones we would send. Around 2027, the Square Kilometre Array comes online. It will be the most sensitive radio telescope ever constructed. Thousands of antennas spread across continents, working together as a single instrument. It will detect radio leakage from civilizations up to 100 light years away. That is roughly 15 times farther than our current best efforts. This sounds impressive, and it is. But consider what we are actually doing. We are assuming that advanced civilizations still use radio, that they broadcast in ways we can recognize, and that their technology resembles ours closely enough for us to notice it at all. Imagine knights in medieval Europe trying to detect electronic mail. They understand communication. They use messengers on horseback. They send letters sealed with wax. They release pigeons to carry urgent news across distances. They decide to search for messages from a distant kingdom. So they check every pigeon coop they can find. They examine every courier arriving at every castle gate. They intercept every sealed letter for hundreds of miles. They find nothing unusual, just the normal flow of correspondence. They conclude the distant kingdom must be empty, or destroyed, or deliberately hiding from them. But the distant kingdom is not hiding. It is not empty. It is full of people sending millions of messages every hour. If those messages travel through copper wires and fiber optic cables and invisible electromagnetic pulses bouncing off satellites, the medieval searchers would never find these communications. Not because they are looking in the wrong places, but because they are looking for the wrong thing entirely. They are searching for pigeons in a world that has moved beyond pigeons. We don't know if this describes our situation. We don't know if advanced civilizations abandon radio technology shortly after discovering it. We have no data on what comes after radio. We cannot study technologies that have not been invented yet. We cannot detect signals we have no instruments to receive. This is not a failure of effort. Our scientists are brilliant. Our telescopes are sensitive. Our search protocols are thoughtful and systematic. Yet the limitation is more fundamental than that. We have been listening for just over 6 decades. In cosmic terms, that is barely a heartbeat. A species that has used radio for little more than a century is scanning for civilizations that might be millions of years ahead of us. The universe might be full of conversations happening in frequencies or mediums we have not invented yet. Gravity waves that carry encoded information. Quantum entanglement used for instantaneous communication. Dark matter interactions that serve as some kind of cosmic internet. Neutrino beams that pass through planets without slowing down. Technologies that manipulate space itself. We don't know. That phrase keeps returning because it is honest. We genuinely do not know what we are missing. We cannot know what we are missing. Yet you cannot search for something you cannot imagine. Here is the surprise buried in all of this. The silence we have detected might not be evidence of berserkers at all. It might simply be evidence of our own technological primitiveness. Both explanations fit the data equally well. Think about that carefully. We have 2 competing theories. One says civilizations are being destroyed. The other says civilizations quickly move beyond communication methods we can detect. Both theories predict exactly the same observation: radio silence. We cannot tell them apart, not with our current instruments, not with our current understanding. The absence of radio signals could mean destruction, or it could mean evolution beyond radio, or it could mean something else entirely that we have not considered. This is uncomfortable for scientists. We want answers. We want data that distinguishes between competing hypotheses. We want evidence that points clearly in one direction. The universe is not obligated to provide that. For decades, we have interpreted the silence as ominous, a warning, a sign that something terrible awaits civilizations that make themselves known. And perhaps that interpretation is correct, but perhaps we have been misreading the evidence. Perhaps the silence is not a warning at all. Perhaps it is simply a gap in our perception, a blindness built into our limited technology, a temporary condition that will change as we mature. We don't know which interpretation is true. We might never know. There is something almost liberating in admitting this. We have spent so long constructing elaborate theories about cosmic predators and ancient machines and civilizations hiding in terror. Those theories are logically consistent. They might even be correct, but they are not the only theories that fit the evidence. The universe might be far less hostile than we have imagined, or far more strange, or structured in ways that make our current fears seem naive and provincial. We are like children listening for footsteps in a dark house. Every creak sounds threatening. Every shadow suggests danger. But perhaps the house is not dangerous. And perhaps we simply do not understand what we are hearing yet. Our uncertainty cuts both ways. It cannot reassure us that we are safe, but it also cannot confirm that we are threatened. We exist in a space between knowledge and imagination, between evidence and interpretation. The honest answer is that we are still gathering information, still building better instruments, still learning how to ask the right questions. The square kilometer array will help. Future technologies will help more. Eventually, we might develop the ability to detect whatever advanced civilizations are actually using. Or we might discover that the silence is genuine, that we really are alone, or that something really is preventing civilizations from flourishing. For now, we sit with uncertainty. We acknowledge what we do not know. but we remain humble about the limits of our perception. And perhaps that is the most important realization of all. Not whether something is hunting us out there, not whether ancient machines drift between stars with terrible purpose, but what it means that we are even asking these questions now. Consider our timeline, not as a civilization proud of its accomplishments, but as a species measured against the age of everything. Human technology, in any recognizable form, is roughly 200 years old. Steam engines, telegraphs, electric lights, the slow accumulation of machines that separate us from every generation that came before. 200 years. We have possessed nuclear weapons for 81 years, the ability to end ourselves, the power to reshape the surface of our world in an afternoon. 81 years of holding that fire. We have had space capability for about 65 years. Rockets, satellites, footprints on another world. 65 years of reaching beyond our atmosphere, and artificial intelligence in its current form, the kind that can reason and create and surprise its makers. We have had that for less than 10 years, a technology so new that the people who built it are still debating what it actually is. The universe is 13.8 billion years old. Set those timelines against each other. Let them sit in your mind. Against cosmic time, our technological civilization is not young. It is not adolescent. It is newborn. It has barely drawn its first breath. There is a way to understand this that matters. Picture a teenager handed the keys to a car. Yes, so they have the physical ability to drive. Their feet reach the pedals. Their hands can grip the wheel. They understand, in theory, how the machine works. But they lack something that cannot be taught. Something that only comes from time behind the wheel, from near misses, from watching other drivers make mistakes, from feeling the weight of the machine around them and understanding, in their bones, what that weight can do. It is not a question of character. It is not about whether they are good or bad, responsible or reckless. A teenager can be brilliant. They can be careful. They can want desperately to do the right thing. It is a question of judgment that only comes from experience they have not had yet. We are that teenager. The keys are already in our hands. The engine is running. We have the power to drive. What we lack is the accumulated wisdom of species who have been driving for millions of years, or billions, if such species exist, if they survived long enough to become wise. This is not an insult. It is simply an observation about where we stand in time. A civilization that has held nuclear weapons for less than a century cannot possibly have the same relationship with those weapons as a civilization that has held them for 10 million years, or that discarded them long ago for something else, or that never needed them at all. The Berserker hypothesis, whether it describes something real or something imagined, has already given us a gift. It forces us to think in cosmic timescales, not next quarter, not the next election cycle, not even the next century, but the next million years, the next 10 million, and the timescales over which consequences actually unfold across the galaxy. This is new for us. Humans think in generations at best. Our institutions plan in decades. Our policies stretch to the edges of living memory and rarely beyond. The future, for most of human history, has meant our children, perhaps our grandchildren, the people we might actually meet. But the Berserker hypothesis demands more. It asks us to consider what our choices mean for descendants, so distant they might not recognize us as ancestors, for civilizations that might grow from what we leave behind, for the entire trajectory of intelligence in this corner of the universe. Even as a thought experiment, this stretches something in us. It builds muscles we have never used. It creates the beginning of a perspective we desperately need. But consider what it means to take the long view seriously. If you genuinely care about outcomes a million years from now, certain choices become unthinkable. Certain risks become too large to accept. Certain technologies require a humility we have not yet learned to practice. The car keys are in our hands. We can feel the power of the engine. What we are slowly learning is that the road stretches farther than we can see, that there are curves ahead we cannot anticipate, that other drivers, if they exist, have been navigating this road since before our species took its first breath. Cosmic timescales humble us. They should, not into paralysis, not into fear, but into the kind of careful attention that a teenager learns, eventually, after enough time behind the wheel. And the kind of attention that comes from understanding that power requires wisdom, and wisdom requires time, and time is the one thing we are only beginning to accumulate. We are not villains in this story. We are not reckless children playing with forces we should not touch. We are simply young, cosmically, almost inconceivably young, taking our first steps into a universe that has been waiting for us for billions of years. The question is not whether we will make mistakes. We will. We already have. The question is whether we can learn fast enough, whether we can develop the judgment we need before the consequences of our youth become permanent. The Berserker hypothesis, true or false, points us toward that question. It asks us to grow up, to think beyond ourselves, to become the kind of species that can hold power wisely across the vast stretches of time that the universe actually operates on. That is its gift to us, not fear, not paranoia, but a framework for taking the future seriously, for understanding that we are responsible not just for tomorrow, but for timescales that dwarf everything our species has ever known. We are cosmic teenagers. The keys are in our hands. What we do next matters more than we can possibly understand. The keys are in our hands, and so is something else, something we rarely stop to consider, what those keys actually start. We have spent this journey thinking about what might be out there, the hunters, the watchers, the ancient machines drifting through the dark. We have asked whether we are alone, and if we are not, whether that company might be dangerous. But there is another question, one that does not depend on what exists beyond our sky. What do we have here? Life appeared on this planet 3.7 billion years ago. Not complex life, not anything you would recognize, just the faintest stirring of chemistry becoming something more. Molecules that could copy themselves, reactions that could sustain themselves, the barest whisper of what would eventually become us. For billions of years, that whisper remained quiet. 3.1 billion years passed before cells learned to work together, before multicellular life emerged. That is a span of time almost impossible to hold in your mind. Entire oceans formed and evaporated. Continents drifted and collided and drifted again. The sun brightened. The moon slowly pulled away. And through all of it, life remained simple. Single cells doing what single cells do. Then, something changed. 600 million years ago, complexity finally arrived. Eyes, nervous systems, bodies that could move with purpose, the slow crawl onto land, the branching and dying and branching again of countless species, each one a tiny experiment in survival. Most of those experiments failed, but some thread continued. Some line persisted through mass extinctions and ice ages and asteroid impacts and the slow grinding of continental drift, through catastrophes that reset the world again and again. And 300,000 years ago, on a small branch of that thread, something unprecedented happened. Awareness, not just reaction, not just instinct, but the capacity to wonder, to ask questions about the stars, yet to feel small beneath them and somehow find meaning in that smallness. Consider what this chain represents. 3.7 billion years of life, 3.1 billion years waiting for complexity, 600 million years of evolution toward intelligence, 300,000 years of humanity learning to think. And here we are, asking about berserkers, worrying about silence, wondering what waits in the dark. The great silence takes on a different meaning when you trace this path. Not just an absence of signals, not just a puzzle to solve, but a reminder of what it took to produce the minds capable of noticing that silence in the first place. Whatever else exists out there, whatever hunters or watchers or empty void, what we have here is the product of almost 4 billion years of persistence against impossible odds. Yet that is not nothing. Picture a candle flame in an infinite dark room. The room stretches beyond measurement in every direction. Cold stone walls that go on forever. No windows, no other light, just endless darkness pressing in from all sides. And in that darkness, a single flame, fragile, brief, barely visible against the immensity surrounding it. A gust of wind could extinguish it. A moment of inattention could let it gutter out. It illuminates almost nothing of that vast room. A few inches of stone floor, a few inches of air turned golden. That is what consciousness might be. That is what awareness, the ability to wonder, the capacity to ask these questions at all, might represent in the cosmic scheme. Fragile things can still be beautiful. Brief things can still matter. The flame does not need to illuminate the entire room to have value. It does not need to burn forever to mean something. Its worth does not depend on how much darkness surrounds it. It simply is, and while it burns, there is light where there was none. The universe does not owe us answers. It never promised explanations for the silence. It never guaranteed that we would understand why the stars remain quiet or what that quiet means. But we owe something to ourselves. The recognition that this phenomenon, this strange capacity for awareness, this ability to look up and wonder and ask impossible questions, may be vanishingly rare, may be precious beyond our ability to calculate, may be worth protecting, not because of what threatens it from outside, but because of what it is. This is not weakness. This is not timidity dressed up as philosophy. This is wisdom, the same wisdom that tells us to handle fragile things gently, to tend flames carefully, to recognize that some things, once lost, cannot be recreated. We do not know if other candles burn in that infinite room. We do not know if the darkness is empty or full. We do not know what the silence means. But we know what we have. We know what it took to produce it. We know how easily it could be lost. Caution is not cowardice when the stakes are this high. Humility is not limitation when what you are protecting took nearly 4 billion years to emerge. The berserker hypothesis may be wrong. The dark forest may be empty. The silence may have explanations we cannot imagine. None of that changes what consciousness is, what it means, but what it cost the universe to produce it, even once. We are the candle, brief and fragile and burning in the dark, and the act of protecting that flame, of tending it carefully, of refusing to let it gutter out through carelessness or arrogance, that is not a retreat from the cosmos. That is the most profound response we can offer it. The question we started with seems almost quaint now. Where is everybody? 4 words that opened doors we did not expect. Behind that first door was another question. Behind that one, another. The nature of intelligence, the risks of speaking into the dark, the patience of machines, the limits of everything we think we understand. Each question led somewhere stranger than the last. We asked where the others were and found ourselves asking whether silence itself could be a message. And we asked about travel between stars and found ourselves confronting mathematics that do not care about our preferences. We asked about ancient civilizations and found ourselves imagining minds made of metal that might outlast every organic thing that ever lived. The journey changed us. Or it should have. Science advances by distinguishing between what we know, what we think we know, and what we are still guessing about. The patterns in starlight, the chemistry of distant atmospheres, the physics of replication across interstellar distances. These sit in the first category, solid ground, tested, reliable, the existence of intelligence elsewhere, the probability of technological civilizations surviving their own discoveries. These sit in the second category, reasonable inferences from incomplete data, educated speculation dressed up in equations. The berserker hypothesis sits primarily in the third category, a guess, a dark one, a story we tell ourselves about what might explain the quiet. That does not make it useless. Guesses matter. They shape how we prepare. They determine what we watch for. They influence which futures we build toward. But we should be honest about what we actually know, which is very little. In 1977, we launched 2 spacecraft toward the outer planets and beyond, Voyager 1 and Voyager 2. Messages in bottles cast into an ocean we had never sailed. Those bottles are still floating. 46 years of drifting. 14 billion miles of empty space crossed. And they have not found shore. They have not encountered anything that was not already predicted by our calculations. No response. No interception. No acknowledgement of any kind. Just momentum carrying them further into the black. We have spent 60 years listening to the cosmos and heard nothing back. Maybe that is because nobody is talking. Maybe that is because everyone is hiding. Or maybe, and I think this is worth considering, maybe we just do not know how to listen yet. Humanity is pretty confident for a species that has only had radios for a century. Our instruments are improving. Our patience is deepening. Our understanding of what signals might look like is evolving. We are not the same listeners we were when this search began. We will not be the same listeners a century from now. The shores those bottles might reach, or might not, depend entirely on choices we make in the meantime. And that is the practical wisdom buried in all of this speculation. Not certainty about what lurks in the dark, not confidence about the nature of the silence, just the recognition that our decisions carry weight beyond our immediate circumstances. Perhaps the greatest gift of the Fermi paradox is not an answer. It never promised us one. The gift is a question that forces us to think in time frames beyond our natural instincts. Human minds evolved to plan for seasons, for lifetimes, at most. We struggle to imagine consequences that unfold across centuries. Millennia defeat us entirely. But this question demands that we try, whether machines patrol the spaces between stars or not, whether the silence represents danger or simply distance, whether we are alone or merely early. And none of that changes the value of learning to think longer. Societies that plan in decades outcompete societies that plan in years. Civilizations that plan in centuries might survive challenges that would destroy those thinking only in decades. What would it mean to plan in cosmic time? Not perfectly, not with certainty, just with awareness that our choices echo further than we can see. The lessons are not complicated. Handle powerful technologies carefully, not because monsters definitely exist, but because some mistakes cannot be undone. Protect what took so long to emerge, not because the universe owes it protection, but because nothing else will provide it. Listen more than we speak, not because speaking is certainly dangerous, but because we have barely begun to understand what we might hear. These are not revelations, yet they are the same wisdom found in every tradition that survived long enough to be remembered. But the Fermi paradox gives them new weight, new urgency, new scale. We are still early in our journey. The shores remain invisible. The ocean stretches in every direction, dark and quiet and vast beyond comfortable imagining. What we carry forward matters. The silence continues. After everything we have explored together, after all the theories and calculations and possibilities we have walked through, that simple truth remains unchanged. The cosmos offers us nothing but quiet. No signals, no messages, no evidence that anyone else has ever looked up at their night sky and wondered the same things we wonder. The great silence. It greeted us when we first turned our instruments toward the stars. It greets us still, and it will likely greet our children and their children after them. The search goes on, but the answer stays hidden. We do not know if we are alone. That uncertainty used to feel like a problem, something to be solved, a puzzle demanding an answer. But maybe we have been thinking about it wrong this whole time. We do not know if something is watching. We do not know if our signals have already determined our future. We do not know if they are spreading outward into an emptiness that will never respond. The not knowing stretches in every direction, as vast as space itself, and maybe that is okay. Maybe the not knowing is what keeps us humble, keeps us curious, keeps us human. The universe does not owe us answers. It never promised to explain itself. It simply exists, ancient and enormous, and indifferent to our questions. But we owe something to ourselves, and to whatever comes after us. We owe the choice to be careful, to be thoughtful, to treat the fragile miracle of consciousness as something worth protecting. That debt exists whether the darkness holds friends or predators or nothing at all. The uncertainty is not a failure. It is a gift. Not knowing forces us to be careful. Not knowing keeps the future open. Not knowing means that whatever comes next, we still have the power to shape it. Certainty would close doors. Certainty would let us stop asking. So the questions themselves are what make us reach further, tonight, or this morning, or whenever you are listening to these words. You exist. You are conscious. You are part of something that took an almost unimaginable amount of time to emerge. Whether that emergence happened once or billions of times across the cosmos, it happened here. It happened in you. That matters. Not because the universe cares, not because some cosmic ledger is keeping score. It matters because you are here to notice it. You are here to wonder about it. You are here to feel the weight of the question pressing against your thoughts. The search will continue tomorrow, and the day after that. New instruments will come online. New methods will be developed. New generations will take up the work that started before they were born. But we listen because we must, because the question demands to be asked, even if no answer ever comes. Because staying curious in the face of infinite silence is one of the most human things we can do. The great silence remains, but so do we. Somewhere out there, or perhaps nowhere at all. The possibilities wait, open, unresolved, still capable of becoming anything. Close your eyes now. Let the quiet settle around you, the same quiet that fills the spaces between stars, the same quiet we have been listening to for generations. It holds no answers, only possibility, and sometimes that is enough.